Good afternoon, folks. This is Mike coming back at you with yet another video on Foundations of Math 2. In the previous video, we talked about permutations and how we can calculate various types of permutations. In this video, we're going to talk about something similar, but not quite the same. We're going to talk about combinations and how we calculate combinations of things. So, again, as I just mentioned, we've talked about permutations. Permutations, just as a quick recap of what the definition is, a permutation is an arrangement of objects where the order does matter. But when we talk about combinations, they are still arrangements of objects, but in combinations, the order in which we have the objects does not matter. Some examples of things that would be combinations: picking the numbers of a lottery. You don't have to get the numbers in the same order as they're picked. You just have to get the same numbers as the ones that are picked. The order in which you have them listed on your lottery ticket versus the order in which they're picked does not matter. Another example of a combination, you have a selection of objects, say fruits, and you can pick a certain number of fruits from that wider selection. Again, it doesn't matter the order in which you pick the fruits. What ultimately matters is what fruits do you have. So if we have n objects, and we're going to pick r of them, and we are not replacing them, we're not going to put them back after we pick them, the number of combinations that we can have is denoted by NCR. This is a little bit different to the previous video where we had NPR, but it's NCR. And by definition, this is NPR divided by R factorial. But in terms of just n and r, it's n factorial divided by r factorial times n minus r factorial. So let's do a couple sample problems here, and we'll see what we come up with. First one here, a lottery sample problem. A lottery operates in which you pick 4 numbers from a set of 10 numbers, and of course the order in which the numbers are picked is irrelevant. We don't care about the order that the numbers are picked in compared to the order of the numbers on your ticket. How many winning combinations are there? So we have a set of 10 possible numbers, and we're choosing 4 of them. So it's going to be 10C4, which, using our formula at the top here, n is 10, r is 4. It's going to be 10 factorial divided by 4 factorial times 10 minus 4, or 6 factorial. And if you plug these things into your calculator, you find that 10 factorial is 3,628,800. You find that 4 factorial is 24. And then you find that 6 factorial is 720. So if you do that 720 times the 24, and then you do 3,628,800 divided by that number, you will come up with, when you plug these things into your calculator, you will come up with 210. So there are 210 distinct winning combinations for this particular lottery here. There is actually a lottery similar, or which operates really based on this same concept. I guess not quite the same, similar. in New York. It's called the Win 4 or the Take 4 or Pick 4, something like that. I believe you can have the same number showing up more than once, though, so that does make it a little bit different, but sort of close, but not quite the same thing. I'll be honest, I don't know because I don't play the lottery. But a lot of lotteries will work in a similar way to this, if not exactly the same thing. Second example here, you have a collection of 32 rare comic books, and you have to pick 5 rare comic books to take home with you. How many combinations of those 5 books can you choose? All right, so again, pretty straightforward. There's a possible 32. We're choosing 5 of them. Obviously, in this context, this is a combination because we don't care about the order in which we pick these things. We only care about what 5 comic books we have when it's all said and done. So it's going to be 32, choose 5, which is going to be 32 factorial divided by 5 factorial times 27 factorial. N factorial divided by r factorial times n minus r factorial. Okay, so you could take these things, plug them into your calculator. You could do all that, and you could come up with what this number will be, and I'll show you how you do that very shortly. But say you didn't have your calculator on you, say that you left it somewhere, and you're like, okay, how the heck do I solve this? We're going to rely on the sort of nice basic properties of the factorial. Recall that by definition, n factorial is the product of all numbers less than or equal to n. So if I work with this 32 factorial up top, I can write that as 32 times 31 times 30 times 29 times 28. And now here I would have times 27 times 26 times 25 times 24 times 3 times 2 times 1. But that 27 times 26 times 25 times 24 times 23 times so on down, that is just 27 factorial. So I can take a larger number factorial and rewrite it as the product of numbers times a smaller number factorial. And the reason that I write it like this, the reason that I stopped at the 27 factorial is because now we have a common factor on the bottom and top. I now have a 27 factorial on the bottom and a 27 factorial on the top, and I can cancel those guys out. So this gives me 32 times 31 times 30 times 29 times 28 divided by 5 times 4 times 3 times 2 times 1. And this, not that it's significantly easier in the context of being able to do this with or without your calculator, but there's just less stuff in here. And now we have this down to just the product of a few numbers, each on the top and bottom, and not long products of several not long products of lots of numbers happening here. So yes, we do still need our calculator, and this is why I said I'm going to show you very shortly how you can do these things in your calculator, permutations as well as combinations. But if you do 32 times 31 times 30 times 29 times 28, you do get 24,165,120. And if you do 5 times 4 times 3 times 2 times 1, you get 120. And if you do 24,165,120 divided by 120, you get 201,376. So there are 201,376 possible combinations of rare comic books that you could choose from this collection of 32 rare comic books. And not that it's the exact same scenario, but you have similar cases happening in sort of everyday life. Say you have a wide selection of, let's say, a wide selection of cans of pop or soda based on whatever term you use. You have a wide selection of cans of a pop that you want to choose for the next party that you're having. Certainly in the world out there, there's at least 32 different types of pop, and you need to pick 5 different types of, or 5 different name brands of pop to have for your party. You know, how many combinations can you have? Well, you can have 201,376. So there's a lot of ways that you can choose 5 different names or types of pop from a collection of 32. Okay, so now the big question is, how do you do these things in your calculator? These are great. I've just said in the previous video, as well as this one here, I've told you what these values were. I've told you what 10 factorial was and 6 factorial and all these things, but how can you actually figure that out on your own? Well, I'm working with the TI-30X-IIS here. The way you do starting off with factorials is you enter the number that you want to find your factorial for. So say I want to find 9 factorial. I'm going to hit 9. Then I'm going to hit this PRB button right here. And we have 3 choices. We have NPR, NCR, and then the exclamation point. If I go over to the exclamation point and I hit enter, and then I hit enter once again, that's going to tell me what 9 factorial is. 362,880. Once more, if I did 14 factorial, this may be too large of a number here. We can see that it's 8.71782912 times 10 raised to the 10th power. So that's a massively large value that we have there. So that's how we do factorials. Say I wanted to do a permutation. Say I wanted to do a permutation of R objects taken out of a collection of N. So N is your larger number, R is your smaller one. I'm going to take my larger number and I'm going to enter it, like 20. I'm going to go to that PRB button. And since this is a permutation, I want NPR. I want the first option that I have highlighted. And let's say I want to take a permutation of 8 objects out of the collection of 20. So I do 20, NPR 8, hit enter, and this is a massively large number that we have here. This is 5,079,110,400. So massively large value that we get here. That's how we do a permutation, where we have a set of n possible objects, and we're taking r of them at a time. If you want to do combinations, again, you're going to put that total number of objects that you have. Again, I'll say 20. go to PRB. You're going to go over 1 to that NCR, hit enter, and then let's say it's 8 once again. So I have 20 objects. I want to choose 8. So I'll do 20 NCR 8, hit enter, and then we have 125,907. Note that there's significantly fewer combinations than there are permutations when you have the same number of objects in a collection and you're picking the same number of objects as well. Significantly fewer combinations than permutations. But really, that's how you do these calculations using your calculator. They all lie within this PRB button here. If you want to do a factorial, go all the way to the right. Sorry, go 3 to the right when you hit the exclamation point. If you want to do a permutation, first one. If you want to do a combination, second one there. So guys, that concludes our video on combinations. In this video, I just wanted to give you a little introduction as to what these things are. Later on in this chapter, we're going to see how we can use these things to find probabilities of things happening. If you have any questions or comments, please be sure to reach out to me, guys. Emails, voicemails, texts, encrypted messages, banners flying high over the football stadium, whatever you have to do. Until the next video, take it easy, guys.